To produce an event like this takes an amazing commitment and also a good deal of sponsorship, mainly corporate sponsorship. We are here in Bratislava celebrating Starmus Earth because of the generosity of ESET, which at last night's banquet, sponsored by them, I also learned can be pronounced ESET. So it's all things to all people. They're a cybersecurity firm that has solutions for home and business and industry, and their customers are some of the biggest corporations on Earth. Our next speaker is their CEO. So my friends, please give a warm Starmus Earth welcome to Richard Marko.
Good afternoon, ladies and gentlemen. Apart from human beings, there are only 4 great apes living on Earth. Most of them endangered, or all of them endangered, and most of them critically. What is perhaps less obvious is that all of them live in tropics, near to equator, usually in jungle. Why it is so? I will leave the proper scientific answer to experts, and we have some of the best of them here. But I can imagine that a jungle in tropics, it must be one of the best places for living. A lot of sunshine, a lot of water, a lot of food, but at the same time, it's a lot of fun, but a lot of danger. So if you want to survive in a jungle, you need to be smart. Great apes are smart. Somehow nested in our real world is a digital world, and digital world is jungle as well. It's a place of a lot of data, a lot of storage, a lot of computer power, a lot of wealth, a lot of human destinies. All of it resides there. It's an amazing place to be if you are smart. Not so much if you are lost. Some of those that live there are predators, and some are food. And learning the tricks, learning how to live there is essential for us to be safe there. There are some simple things, and let me start with simple things. So you can get an email. An email can look like this. It seems to be coming from a DHL, and it says like, there is a package waiting for you. Now, you are not expecting any package, but curiosity in you is telling you, okay, let's inspect. There is a link easily available to be clicked. Quite often, for the predators of the digital space, the cyber criminals, this is all it takes for you to get infected, for their attack to be successful. So you need to be careful. You need to be careful that those things that are used against us, like curiosity. In this case, I have another example about Netflix, and Netflix is saying like, well, you better check it out because your renewal will not happen. Again, like, click on the link. So in this time, like, if you are addicted and you are keen on watching your next series, well, that's hard to avoid, like, the desire to click on it. You can have a company writing to you like, well, there is something suspicious going on. So again, better check it out. So it's using responsibility, which is encoded in us, to lure us into doing something. Or it can be like somebody saying, like, I have some trouble, please send me your WhatsApp number so that you can help me. You know, like this, again, the sense of responsibility, and there is an urge to do something. That's usually what is present in such cases. Is it easy to spot this kind of attacks? Well, not always, because we are not all the time very careful, and so these kind of messages are coming all the time. We get tons of emails, so it's not so easy. But if it is something you are not expecting, it's something that is pushing you into doing something quickly, you should be careful. But these types of attacks are very general. They can happen to anybody. Now, imagine that you are an employee of a Polish distributor, and you get an email that seems to be coming from the CEO of a vendor, which is the most important vendor for your company. So this is the type of attack that is more targeted. So email like this is sent to a particular recipient, expecting that the recipient knows, in this case, my name, and that I am the CEO of the vendor, and that in this way creating, again, this push of like, well, this is the CEO, we rather react. But because the distributor in Poland is in the cybersecurity business for a long time, they forwarded the email to us, and now suddenly the roles of predator and the prey reverse. We create an account, Robert with a Polish-sounding name, and we continue the conversation, and we are trying to find out what is going on. And now the indication is, well, there is a shipment that we would like you to handle for us. And so we are asking like what it is, can you provide more details? Then the details are not really details, because it's a 7.5-ton, 10-meter long machine that is supposed to be shipped to a port in Poland. And not surprisingly, it doesn't take long until there is an indication that something needs to be paid. Okay, so we continue the conversation. We are trying to find out the details, and then the invoice is sent. And the invoice is just telling, like, this is the machine, all right, and this is the account in the Bank of China. All right, so we continue playing the game, saying, like, well, it's going to be difficult to send money to China, so do you have some kind of European place, just to find out how flexible they are. And they are quite flexible, because they respond, yeah, there is a bank in China, you can send it there. The bank seems reasonable, the account number seems to be legitimate, and there is an address, so it's not so difficult in these days to check it out a little bit, especially because we have a partner also in Spain, and the partner is residing not far away from there. It's in the east of Spain, and this is the street view. It's nothing very interesting here unless you pay more attention, and I will help you a little bit. I would say I don't expect the FBI trucks to look like this, so I suppose it's just an unexpected coincidence that happened in this case. Anyway, what followed was we just provided the information to police in Spain. We don't know exactly what happened afterwards, but later we read a note that a gang operating in Spain by people coming from Africa, Nigeria, but also other countries was arrested. It was quite a big operation, successful operation by Spanish police. So I got interested in computer science long time ago. When the first time I heard that there is something called computer viruses, I was shocked, like, what is that? And I think I was not the only one, because Stephen Hawking in 1994 said, I think computer viruses should count as life. And he added, I think it says something about human nature, that the only form of life we have created so far is purely destructive. You can say, the only form, and what about ChatGPT? Okay, this quote is from 1994, and we will get to ChatGPT a bit later. Now let's go to something even more serious. And I will a little bit unexpectedly start with a joke. It's an old joke, a geek joke, and it says, there are only 10 types of people in the world, those who understand binary and those who don't. Some of you are laughing, and some of you are not. So either it's really an old joke that you know, either you understand binary or you don't, right? So the pun here is that what we read as 10 in binary is a combination of 1 and 0, and the value of this combination is 2. So that's the kind of trick in this joke. So let's see the binary. This is the code in binary. This is a real code. This is a real malicious code in binary. And there are zeros and ones. Probably everybody heard, like computer zeros and ones, not helping much to understand anything, but this is how it could look like. If you understand this code and you are not yet working for ESET, then please contact me after the presentation. I can tell you, I worked in R&D for 20 years and I never saw a code in this form. So reading it directly from binary doesn't make much sense. More often you can see something like this. This is the same thing, but expressed in hexadecimal. For normal human beings, not easier to understand, but there is a human readable form of the code that looks like this. And maybe you think, human readable? Who can read this? Okay. I can't read Arabic, but there are many people who can read Arabic. And if you spend some time with assembly code, this is the assembly code, really machine code, then you will learn it. It's not so difficult. It's much less difficult than you think. Anyway, there are instructions here that you can see that the computer is able to understand. Now, I said this is a malicious code. This code is coming from malicious piece of software that we call Trojan Downloader Amadei A. The name is not so important. It's a real existing malicious code on market since 2018. Remember, on market. So you can buy it for roughly $500 on Russian forums. And it's a piece of malware that is able to install other type of piece of malware, including ransomware. Now, what you want to achieve is that it doesn't run on your computer. We want to achieve that it doesn't run anywhere. So what we can do? So let's go back to the code. We can select a part of the code, and you see the selection of the hexadecimal form of the code, and use it as some kind of search string. So you will search for anything that is happening in the computer for this string. You can select other string. And that's exactly the trick. How you select the right string, it's not so easy, because there is so much data on the internet. So if you select a wrong piece of the code, then you will get so-called false positives. You will say that something is malicious when it is really not. And then imagine that there are millions of malware samples that you need to detect. So this is very inefficient way of detecting it. Okay, so what about like computing some kind of hash of all the code that is contained there? Might not be so obvious, but this is much better techniques, because it can be done in a way that is quite efficient, and it actually works and is being used in the real world, but still is not very advanced techniques. It will not help you in situations when you don't know what to expect, when the new samples, new malicious code is appearing all the time. So then you can have a look in the code and notice there is an instruction called write process memory. Of course, most of you are not familiar with that, but I can tell you that this is an API call to the operating system that wants to tamper with a memory of another process. This is a very unusual behavior for any code. So now you might think, okay, so now I am a cybersecurity expert too. I can write an antivirus software or something like that. Well, not so fast. Unfortunately, the coders have this curiosity and they are learning new things. And they are especially keen on learning things from malicious code, and then they use it in their legitimate application. So it doesn't make much sense, but there is a lot of legitimate applications running in the world. So if you have your detection based on this, it will be tons of false positives. Now, there are other API calls here in the code. And then you can see there are some other references and so on. This is going already in the right direction. But now, a moment that I would call Deus ex machina happens, that I will skip like the details and how it's done because it's a little bit complicated. And it's also a trade secret. But imagine that you are able to extract some kind of digital signature, not really signature, it's more like a DNA, digital DNA, that goes beyond API calls, particular instructions, and of course beyond the binary representation, and looks at the real nature of the code. And I'm referring to DNA because this is really what it is in the end. So if you have something like, for example, chimpanzee DNA and human DNA, and the scientists are saying they are 98% similar. So we want to have something similar for code. And so for the example that I was giving, the Amadei A, there is a variant that we call Amadei B, and this technology can tell you like it's 95% same. And now imagine you have this technology and you deploy it on millions of computers around the world, in data centers, on the computers in telecommunication operators, so that the communication between the mobile devices goes through that. And the technology is able to inspect the communication, inspect the code, inspect the data that is passing through that, is able to look into the chips, into the flash memories of the computers. And you have an agreement that you are able to receive the information about what is detected, like suspicious behavior. What do you think would happen? Well, I can tell you, it will be a mess. It will be, at that moment, your thumb will be on the pulse of cyber world, and you will see the never-ending battle of good and bad. The malicious, alleged code appearing everywhere. And in the end, you will see 750,000 suspicious files a day, 60 million different metadata that are related to that, and 2.5 billion different URLs that you need to analyze. And so you need to have a really smart system to be able to process all of the data, store it, and work with that. And then the finance department will start to complain why you need to buy more and more disk space and more computing power and so on. So let's move to something even more tricky and difficult. So this is some kind of data, and you see there is a sudden spike. This is number of interaction of our Twitter account where we publish the results of our research, and the spike happens on February 23. And it was not February 23 this year, but it happened in 2022. And we didn't know back then, but what we discovered was a massive malicious attack on critical infrastructure in Ukraine. So when we published it, there was a massive interest from the world, and it was just a few hours before the full-scale Russian invasion to Ukraine started. How we were able to be there? Well, the history was a lot longer. By that time, we were already running on roughly 90% of Ukrainian critical infrastructure. Yeah, this is the tweet. And we had a long-term experience with all the different types of attacks happening in Ukraine. And there was a lot. In 2015, black energy caused blackout for parts of Ukraine for a couple of hours. That was quite sophisticated attack. But a year later came even more sophisticated attack in form of industrial. That was a piece of malware that was directly able to talk to industrial devices, to the switches, and in this way achieve the blackout. And then there were telebots, like a family of malware that eventually distributed the infamous NotPetya attack, the biggest ransomware attack that started in Ukraine and then infected the whole world and caused major disruptions and everywhere. It took us some time to realize that there is a link behind all of this, that exactly when we compare the DNAs that I talked about earlier, they have similarities, that they are related, that there is probably one group or related groups of individuals behind those attacks, and they are well coordinated. And of course, after the full-scale invasion, it didn't stop. There were many attacks on infrastructure in Ukraine, some successful, some not. For example, the next version of Industrial, the attack was stopped before any blackout could happen. So the defenses are improving all the time. There are these types of attacks are happening everywhere. Middle East, of course, if there is a war, if there is some unrest, if there is geopolitical tension, then you see these kind of things. It might be espionage, it might be disruption of the operations. Europe, many attacks on particular industries, or on diplomats, like high position individuals. Supply chain attacks, that's a really interesting topic, because you might have very good defenses and you might be able to avoid being successfully attacked, but each company is using many suppliers, and each company is using many software that is a lot of software coming from other companies. And if those other companies get infected and the software you are getting from them gets infected, well, then you are in trouble. So this is called a supply chain attack, a very difficult type of attacks. Of course, crimeware. Sometimes we are lucky, we are successful, we are able to disrupt the operations, that the networks of infected computers operating in the world can be, the control of the network can be taken over by not the attackers, but the defense, and the whole network can be disrupted and the operation stopped, and that's nice. This is an example from this year. Okay, now we talked about a lot of data coming from anywhere in the world, and if you have a lot of data, then this is an opportunity for artificial intelligence, deep learning. And that's at the heart of what we are doing and what other cybersecurity companies are doing. So we are receiving, we have a collection of 65 terabytes of data, and then every 8 days, a cycle starts when this is again processed, and then a deep learning applied on that, and then a new neural network created, and then it's converted into a module, and then tested, and then distributed to many, many computers around the world. And that's the cycle that happens all the time because the world is changing. Now, I'm talking about AI, and you think like, okay, and what about ChatGPT? Well, ChatGPT is, everybody is using ChatGPT. ChatGPT will solve everything, write poems, and do anything. Well, there are probably some jobs that are endangered by ChatGPT, but I can tell you one that is not, very likely not. Cleaning a house is a job that is really difficult. Imagine the quality of vision that you need to have, quality of coordination, of spatial movement, then the recognition of the surfaces, distinguishing what is clean, what is not. This is going to be very difficult to be converted into a robot. Now, going back to cybersecurity, and this is where I will finish, is imagine you have an attack. This is a ransomware attack. This is one way this can be visualized. So you have different computers involved, different users, different identities. There are different processes, there are different links, there are different detections. For a normal human being, this is a mess, of course. Then the tool can make it easier, make it interactive. You can learn more information by clicking and so on. But it's still a difficult task, really difficult task that researcher, like cybersecurity expert, needs to do to understand what is going on. And so here is where the ChatGPT or large language models come in play and are starting to be used, because you can use the information that is coming from behind as an input data for the large language model, and then have an advisor, an AI advisor that you can ask, like, well, give me the basic overview of the attack. And the assistant, the advisor, based on all the information, and will give you an overview of the processes, what is their role, how the different techniques were used. And then you can go further, for example, ask about how the identities are being explored so that the malware is able to spread further in the network. So then you have a more detailed explanation about how this is done in this piece of malware. Then you can go how it is maintained in the system. Again, more information. Then it can give you even indication what attacker group is behind all of this. And this is the future. This is the future of cybersecurity. Like AI plays a key role in our ability to process all the data and then to select what is okay, what is not okay, and then how to respond and how to stop the attacks as quickly as possible. And we see our role not only as technology experts. It's not only about research, it's not only about technology, but it's really about making sure that the digital world we all live in is a safer place, and is a place that is helping for the progress to continue. And this is our mission. Thank you very much.